Hi, this is a course overview of 6.2. The concept on this one is one-to-one functions. Actually, there will be another video for 6.2, and it will be about inverse functions, so that one will be coming up. But one-to-one functions, what they are is just, I'm going to put it down as simple as I can in words, and I'll come up to the board for it with you. What it is, a one-to-one function is every output can appear one time. So if you put an X in and that output, it gives you an output, that output cannot reappear with any other input. So for every Y, there can only be one X that goes to it. So I call it the honeybee syndrome, because honeybees can only sting one time, and so that's it. So this is a function. When an output happens, it doesn't happen again. So anyway, here's my definition. A function is one-to-one, provided for each output there corresponds only one input. For each output appears once. Okay, so the actual definition kind of looks probably a little familiar to you, because the definition of a function is for each x there's only one y. Okay, so if you put something into a machine, it can only give you one output. But that's the definition of a function. But this one goes one step further. Sure, one thing in gives you one thing out, but that one thing out only can happen once if it's one-to-one. But to be a function, that's not necessarily true. Just to be a function, I can put a number into a machine and get an output. Something else can be put into a machine and get that same output, and that would still be a function, but it just would not be a one-to-one function. So there's a little discrepancy there. So now, the horizontal line test is a test that tells you about one-to-oneness, just like the vertical line test will tell you whether it's a function or not. This one will tell you whether it's a one-to-one function. And what the horizontal line test states is a graph represents a one-to-one function if for every horizontal line drawn over the entire domain, it intersects the graph at most one point. So this example that I gave you right here, these first two examples, will talk about the horizontal line test. If you draw a horizontal line through this graph at any point you like, it hits the graph at one place. So this graph is a function, and it is one-to-one. So this one is a one-to-one function. Now the next one is a function, because it passes the vertical line test, which we talked about in section 3.1. But in 6.2 here, we want to know if it's a one-to-one function. Well, if you draw a horizontal line, now if you draw it here, it looks like it might be hitting the graph at one place, but actually it doesn't. The graph actually goes up. But since it's over the entire domain, even if you find one place that a horizontal line will hit it at one place, that's not good enough. If any place else we draw that horizontal line, if you bring the horizontal line down here, it obviously hits it at 4 different places. That's definitely more than one. So this one is a not one-to-one. It's still a function, but it's not a one-to-one function. So now this would be a good time to stop just for a second to talk to you about why is one-to-one important. Well, that's going to help us in our next part of this section 6.2 about inverse functions. Now, let me explain to you what an inverse function is, at least right now, and then I'll explain to you why is it important that it's one-to-one. What an inverse function does is it's another function, and what it does is if you have one function that gives you, put in A and it gives you B, well, what the inverse does is it takes B and gives you back A. So if you put 1 into a function and get 2, what the inverse would do is it would take 2 and put it back into another machine and give you 1. That's what an inverse function is. We'll talk about that a little bit later. But the reason a function have to be one-to-one to have an inverse is because if that doesn't happen, let's say you put 1 in and it gave you 2, and you plug 3 in and it gave you 2 as well. Okay, so you got 1. So 1 gives you 2 and 3 gives you 2. That is not a one-to-one function because 2 appear twice. Okay, but this is why it's important in the inverse analogy here. The inverse will go backwards. So if a function is one-to-one, like 1 gives me 2 and then 3 gives me 4, Well, what the inverse is going to do is it's going to say, well, I'm going to put 2 back in the machine, it gives me 1, and 4 back in the machine, it gives me 3. And if it's not 1 to 1, then where is 2 going to go? Is 2 going to go to 1? 2 is going to go to 3. Well, logic dictates that it's got to go to both. Because if you're going to talk about inverse, that's what they do. It just does everything in reverse. Well, if it goes in reverse, it has to go to both numbers. I think that contradicts something. It contradicts the definition of what a function is. 2 in, 2 numbers out. 1 and 3 is out. That contradicts the definition of function. That is the sole reason we talk about one-to-oneness, is because it sets us up for the next step, which is inverse functions. So this section is a fairly easy section to do, but you got to understand the bigger picture of everything here. The bigger picture is the inverse functions. But it's very easy to determine whether a function is one-to-one or not. Now, these next 2 examples is, like I said, it's really simple to determine this. But 2 gives me 3, 3 gives me 5, 4 gives me 6, and 7 gives me 9. There is no output that's more than one time. So this one is a one-to-one function. And the last one, y equals x squared minus 9, is that equation a function or not? Well, there's a couple of ways you could do it. You could just plug some numbers in until you run across one that maybe repeats itself. But there's another way you could do it if you think about it. Think of the horizontal line test. And think about something we did back in chapter 3 when we were graphing parabolas. So y equals x squared minus 9. That is a parabola that's been shifted down 9 units back in 3.5. So, but at the end of the day, it's a parabola. So this graph actually was way down here and it goes up. And so obviously it is not one-to-one because it was failed a horizontal line test. So you could actually start putting some numbers in until you run across some 2 numbers that are the same. For example, if you plug in, let's say 1, you'll get -8. If you plug in -1, you'll also get -8. And so -8 appears twice. That's a little bit more messier to do it that way, though. And if you just think, oh, this is a parabola. And the thing about one-to-one functions is there can't be any turning points. They have to be monotone up or monotone down, meaning they have to continually up and continually go down. You can't have a little bit of both, because the moment you have a turning point is the moment you're going to have 2 y coordinates that repeat itself. So that is the reason they have to continually go up or continually go down, but none of these turning point stuff. Because when you start turning around, you got to have 2 y coordinates that are repeated. So, but in itself, you'll find 6.2, this part of it, very easy to do on your homework. It's the next part, that's the next part of 6.2 is going to be a little bit more difficult.